Today, let's talk about the impact of Line 5 and climate change. We've known for years that the existing Line 5 running along the lake bed of the Straits of Mackinac poses an immediate and unacceptable threat of an oil spill in the Great Lakes. Governor Whitmer revoked Enbridge's easement to operate the line, though the company has refused to stop operating. Instead, the company's banking on a last-minute agreement brokered with the prior administration to build a tunnel under the straits, a disruptive and dangerous undertaking that will leave the existing line in the straits for years. So we know that the existing Enbridge Line 5 poses an immediate threat to the Great Lakes, but how does Enbridge's proposed replacement tunnel stack up from a broader environmental perspective? ELPC and our colleagues and clients at the Michigan Climate Action Network are looking at just that question. We intervened in front of the Michigan Public Service Commission, which is one of the agencies charged with evaluating Enbridge's request to locate a tunnel under the straits. From the beginning of the case, we've advocated for the importance of including the impact of climate change as part of the Commission's required environmental review. The reality is the replacement tunnel is connected to climate change on a local, national, and global scale, and represents a continuing commitment to fossil fuels that undermines rapid action on climate change. Today, we're honored to have Dr. Julia Cole of the University of Michigan to talk with us about this issue. Julia is a professor in the Department of Earth and Environmental Sciences, where she teaches as well as leads a research lab that focuses on climate and environmental change in systems with large societal impact. After we hear from Julia, we'll have plenty of time for questions and answers. To ask a question, click the Q&A icon on your screen and type in your question or put it in the chat. You can do that at any time during the presentation or the discussion, and we'll get to as many questions as we can over the time that we have. I want to thank you so much, Julia, for being here. Let's hear from you, and then we will discuss further.
Thank you, and I'm really looking forward to this. Let me share my screen. All right. Well, thank you for the opportunity to speak with you today. It's really exciting to be able to address this group, and I really look forward to the Q&A. We already know how fragile this pipeline is and the risks that it poses to the health of the Great Lakes ecosystems and adjacent communities. What I'd like to do today is explore a little bit how Line 5 fits into the broader context of climate change. Oops. Now, we have known for more than a century that burning fossil fuels creates carbon dioxide that will lead to a warmer planet. But that knowledge has always been framed in terms of someday in the future, when we have to get our act together and reduce CO2 emissions to avoid consequences by, say, 2100. Now, anyone who lived through the last summer knows that the future is, in fact, already here. We saw heat waves with temperatures that obliterated past records and led to hundreds of deaths. We saw wildfires in the Western US that razed entire communities. And this summer came on the heels of an even worse wildfire year in 2020. Drought across the Southwest entered into its third decade. So yes, this is a mega drought. The Colorado River, which is the lifeblood of the Southwest, supporting over 40 million people, dropped below critical levels and prompted the first ever shortage declaration and water supply cuts to Arizona farmers. Here in Michigan, intense rainfall led to devastating floods across the Detroit area, and Hurricane Ida devastated the Louisiana coastline before bringing deadly flooding into New York and New Jersey, killing at least 65 people across 8 states. Outside the US, we saw similar climate chaos. Heat, drought, and wildfire ran rampant across the Mediterranean from Spain to Turkey. And further north, flooding raged through towns in Germany, Belgium, and elsewhere. Heat waves across Scandinavia, Kazakhstan, and Russia made the news, as did flooding in southern China. And although the media attention tends to focus on climate disasters in wealthy and powerful nations, in fact, it's those who contribute the least to climate change who lose the most from its impact. In the developing world especially, consecutive climate shocks from drought, heat, and storms are compounding other sources of vulnerability and undermining food security. Now, these climate patterns are not, unfortunately, surprising. In fact, they are exactly what we expect in a warming world. Nor are these one-off one-year events. These are trends that have been growing for some time. Warmer temperatures lead directly to more intense rainfall, coupled with longer dry periods between storms, and warmer temperatures shift patterns of precipitation, increasing it in middle and high latitudes, like here in Michigan, and drying out the subtropics and lower mid-latitudes, like the Southwest and the Mediterranean. Here, I'm showing maps of projected changes in soil moisture, which is a combination of temperature and precipitation, for various levels of global warming. The Intergovernmental Panel on Climate Change also released a major report this summer, and they confirmed what many scientists have been saying for decades. There is a direct link between extreme heat, drought, and flooding, and the globe's warming temperatures. They highlight that every increment of warming brings added risk of climate extremes. So today, global temperature is 1.2 degrees C above pre-industrial levels. By the way, every time I give this talk, I think I have to change that number. It's very depressing. Today, with 1.2 degrees C warmer than pre-industrial levels, our climate risks are higher than they were in the 19th century. The risks, if we warm to 1.5 degrees, will be greater than today. They will be higher still at 2 degrees C. And in fact, if we warm as far as 4 degrees C globally, we will face what seems like a whole different planet in terms of climate extremes. The warming climate also brings the risk of crossing what climate scientists call tipping points. You're probably familiar with that term from Malcolm Gladwell's book. Climate scientists use this term to refer to what happens when we push a natural system over a threshold into a different state from which it is impossible or difficult to return, and a state that often has cascading consequences. So an example of this would be the melting of large ice sheets. Particularly vulnerable are the West Antarctic and the Greenland ice sheets, which together hold about 11 meters of sea level rise. That's about 36 feet. It's much easier to melt large ice sheets than it is to build them back up again. Scientists are now documenting how warmer air and ocean temperatures are leading to accelerating loss of ice mass in both Greenland and Antarctica. Some are already calling this unstoppable. Another tipping point lies in the Arctic, where warming is melting permafrost across high latitudes, which has the potential to release vast stores of carbon that it has accumulated in these frozen soils over the past several thousand years. The warming Arctic, in turn, changes the atmospheric circulation around the entire northern hemisphere, particularly how the jet stream behaves. And this changes climate patterns right here where we live. Now, tipping points are important in ecosystems too. For example, across the tropics, we have already lost about half of the world's reef coral. We are on track to lose much of the rest of it as oceans become warmer and more acidic. Once corals die, reef structures become colonized by algae, and the regrowth of those corals becomes much more difficult. About 25% of all marine species spend some part of their life history on coral reefs, and hundreds of millions of people depend on reefs for sustenance or economic benefits. So a world without coral reefs is more impoverished, both in terms of biodiversity and in economic terms. So we are at the point now where we not only anticipate dangerous climate change in the future, we are starting to experience it. The international community long ago agreed that avoiding dangerous climate change was a common goal. They have met annually since 1995 to identify how to avoid such change. And these are the so-called COP meetings, of which the meeting in Glasgow last month was the most recent. Now, the goal of avoiding dangerous climate change sounds pretty attractive, but defining what you mean by dangerous has proven a little bit slippery. For many years, a cap of 2 degrees C warming was identified as a threshold beyond which danger lay. In the COP21 meeting in Paris, however, a group of countries known as the High Ambition Coalition called out the risks associated with 2 degrees C warming as unacceptable. And the agreements coming out of Paris and later coming out of Glasgow highlighted the need to limit warming to well below 2 degrees C and more recently down to 1.5 degrees C. This High Ambition Coalition is was begun by Tony DeBrum of the Marshall Islands, where sea level poses an existential threat. The IPCC took up the challenge to identify what a 1.5 degrees C limit would mean in terms of climate and environmental risks. And now we have a solid body of science supporting the goal. And this has been apparent most recently as a goal for emissions in Glasgow. So if we want to cap warming at any level, 1.5 degrees or higher, that means we have to cap the atmospheric concentration of greenhouse gases. Think about that for a minute. Any greenhouse gas emissions into the atmosphere increase those concentrations and therefore increase the temperature. This is why a goal of net zero emissions is so important. To cap warming, we need to zero out our net greenhouse gas emissions, not just bend the curve, bring it down to zero. It's important to recognize that the amount of warming is proportional to the amount of greenhouse gases in the atmosphere. And this means that if we want to limit temperature warming to 1.5 degrees, there is a finite and determined quantity of carbon that can be allowed to be emitted. In other words, we're on a strict budget. We have a bank account of emittable carbon, and once we've gone through that, no more. Okay. So globally, this budget is around 500 to 600 billion tons of CO2 equivalent. Equivalent just means that other greenhouse gases are accounted for in this. Right now, we emit about 52 billion tons per year of CO2 equivalent. So you can see the scope of the challenge. 500 to 600 billion tons allowed, 52 billion per year. It gives us a little over a decade, maybe, of emissions at the current rate. Moreover, this is the bank account for all the world's countries together. Those who use fossil fuels somewhat lavishly to support a very comfortable and wealthy lifestyle, and those who are using fossil fuels to bring people out of poverty, provide electricity where there is none, and provide clean cooking fuels where those are unavailable, and support education and development. So you can see the scope of the diplomatic problem here. Sorry, the sun is in my eyes here all of a sudden. I'm stepping around to avoid that. Okay. More critically, emissions are still rising. Every year we're dipping deeper into that bank account. And the more we spend now, the less we have to spend later. The most recent COP meeting in Glasgow summarized every country's self-determined commitments to emissions reductions. And we are still a long ways off for what's needed to stabilize warming at 1.5 degrees. So here's a figure coming out of a group called climateactiontracker.org that highlights emissions on the vertical axis and time on the horizontal axis running from 1990 up to 2100. The historical emissions are in black, and you can see that at 2020, we have several pathways along which we could go. Now, the policies, the real world policies and actions that countries are taking will take us along that fat blue line at the top, which would restrict warming to somewhere between 2.5 and 3 degrees C. If countries follow their commitments for emissions reductions that they put out at Glasgow, we might get down to 2.4 degrees C warming. If we look at all the pledges that countries have made, including long-term pledges beyond 2030, we might get down to 2.1 degrees. And if we include the optimistic scenario with all announced net zero targets, regardless of how binding they are, that are very long-term, we might make it down to 1.8 degrees. What we need to do is be on the green track, which is the track that leads us to 1.5 degrees. So even in Glasgow, we did not get to a point as a global community where we have committed to reduce emissions sufficiently to keep us out of the danger zone. Now, cutting emissions is hard, but there are easier ways and there are harder ways. And I'll give you an example. Renewable energy sources like wind and utility scale solar are already cheaper than coal and gas in most markets in the US. We can bring renewable energy online using these established technologies and shift to electric options for heating, cooling, and cooking. We can shift to all electric vehicles to dramatically cut emissions from petroleum products. Electricity accounts for nearly 1/4 of our current emissions, and transportation is another 21%. So this would make a big dent, all with technologies that are already common today. The food system is another major source of emissions, and strategies to reduce emissions there range from the personal, like dietary shifts to a more plant-based diet, which is one of the most effective things that one can do, to land management approaches to keep carbon in soils, and to strategies that increase yield and make production more efficient. reaching net zero will not be easy, and we need innovation and new technologies as well as these more established ones. But I think if there's one thing that should be obvious from this, it's that new investment in fossil fuel infrastructure works absolutely against this idea of getting to net zero emissions. It's absolutely counter to this urgent goal of cutting fossil fuel emissions to zero. When you are in a hole, and we are in a really big hole emissions-wise, the first thing you need to do is to stop digging. Every investment we make that supports fossil fuel infrastructure is a dead-end investment. Line 5 and the tunnel that is being proposed to replace it is part of the vast network of pipeline that supports the fossil fuel-based energy system that we need to replace with renewables as fast as possible. So it's a bad investment. In addition, so then to wrap up, in addition to this well-documented fragility of the current pipeline and its direct risks to the health and quality of the Great Lakes, the pipeline and the tunnel represent exactly the kinds of investments we need to avoid. These are investments that make it all too easy and all too comfortable for us to continue an unsustainable and increasingly dangerous dependence on fossil fuels that will lead to unacceptable increases in climate risks worldwide, particularly to populations who are most vulnerable and least able to adapt to those risks. So with that, I'll stop. And I would love to take questions from you on any aspect of this. Thanks.
Great. Thank you so much, Julia, for that, both sort of very heavy, but also, I think, hopeful presentation. One thing that I struggle with a lot, especially I've noticed in this case we have at the Public Service Commission, is that some of the folks who want the tunnel to be built and this investment to be made feel like they've kind of given up. Like there's not much we can do, and it's either we're going to stop climate change or we're not going to. And there's sort of no middle point. It's we're successful or we're not. And so if we can't stop all the fossil fuel infrastructure, then what's the point of stopping this one project? What do you think about that, attitude towards climate change?
Yeah, it's easy to go immediately from denial to despair, right? In terms of this problem. I would say one of the things that's really clear from the IPCC is that every little bit of emissions matters, right? So the risks at 1.5 degrees are less than the risks at 1.6 degrees. They're less than the risks at 2 degrees. So every bit we can cut back emissions and keep the rising and stem the rise of greenhouse gases in the atmosphere is a step towards a safer climate system.
And so the experts in the MPSC case looked at greenhouse gas emissions from the extraction of the oil that will flow through the tunnel, and also from the refining or the end use of that oil. So is that an important thing to do when you're looking at greenhouse gas emissions, and why?
Yeah, is it important to quantify the amount of carbon that's being released? Well, first of all, I noticed that one of the things they did is they took the big picture, right? The whole story of carbon emissions, ranging from the extraction of the oil to the construction of the tunnel to the end use of the oil that would flow through there. And it's important to do that because we are moving into a world where carbon accounting is going to become a real need, right? And so for this particular project, I find it very easy to simply say that any support of new fossil fuel infrastructure contributes to the problem, right? So my gut feeling is I think we should have a default no on those kinds of questions and not try to calculate every bit of carbon. But it is important to calculate that carbon from another standpoint, which is that as we move into a world where carbon becomes increasingly regulated and we are starting to be held to meeting targets on emissions, we need to know where those emissions are coming from, right? So it's important to be able to quantify that. And a particularly tricky part of that quantification is moving from the emissions to the cost, right? The social cost of carbon is yet another step if we want to do this from an economic standpoint.
Right, yeah, exactly. And we, in that case, did have an expert Pete Erickson, who quantified the emissions, and then another Peter Howard, who talked about that social cost of carbon. And just to kind of tie in a little bit, how you referred to line 5 to the tunnel as like new fossil fuel infrastructure. So there are a couple questions in the chat about, well, how would the building increase emissions, or how is it new infrastructure? So just kind of level setting for folks that, the line itself, the existing line, has been shut down by the governor. Now, it hasn't stopped running because Enbridge hasn't stopped running it, but it has been shut down because it's just so dangerous. And so the real question in this case is not, are we going to replace this existing line somewhere else? No, the question is, we've shut down the line because it's too dangerous. Are we going to build a tunnel so that we can restart this line? So that's how it's new fossil fuel infrastructure. And you talked a little bit, you said that some folks in your field are referring to warming as unstoppable. Do you believe that?
So I was referring to the melting of ice as unstoppable.
Okay.
Because once you set some things in motion, it's very hard to stop them again. And once you start exposing ice to warm ocean waters around it, the ice in Antarctica in particular, I'm thinking of here, that is a situation that you set something in motion that's very hard to reverse. However, I don't think the warming is unstoppable, because the warming depends on the amount of greenhouse gases in the atmosphere. And if we can slow the growth of that and bring it back down, we can slow the warming.
So another question that comes up a lot in these cases are, the economic impact of not investing in fossil fuel infrastructure, or of shutting down an existing infrastructure. And one thing that I don't hear an awful lot about is kind of the other side, like, well, what's the economic impact of not doing it? Do you have any thoughts on that?
So I am not an economist, and I have not been calculating these things from an economic benefit. But what I can say is that we think a lot about the cost of adapting and mitigating climate change. And what we've seen in the last year is that the cost of letting it proceed unabated is massive. And so I feel like the cost of moving forward to stem those kinds of losses that we've had is something that is extremely high. Well, we have to stem those losses, and we have to reduce those losses as well. So, and we're not calculating those, perhaps taking those into account when we think about those costs. Margaret, I have a question for you. The timescale of construction of the tunnel, as I understand it, is long. Can you remind me what the estimated timescale is?
So the most recent estimates that we've seen, and these came after the National Wildlife Federation had to file a lawsuit to get a FOIA response from the state, is that the tunnel would not be completed until around 2028. So it's a very long process. And there's a lot of concern about the fact that right now, though the governor has ordered the line to be shut down, Enbridge has not stopped operating. It continues operating in violation of that order. And it, I assume that Enbridge would continue to operate it for that 8 years. So that's kind of the time frame that we're looking at.
And so it would come online just at the point where we are committing to cutting our carbon emissions in half by 2030, right? And yet the tunnel won't come online until then. And it's unsafe to operate the pipeline between now and then. So I feel like the timing of this is just going in the wrong direction as well.
Yeah, and so some of these, like the climate goals and these kind of like touch points that I think lots of states, including the state of Michigan, have set for themselves. How do you think those play into this idea of like the bank account that you talked about? Like, how do we reconcile all of these different goals that are being set with that bank account that is very real?
Yeah, so that bank account is a hard and fast constraint if we want to keep warming to 1.5 degrees. If we want to do that, we have to hit net zero emissions by the middle of this century. And that's something, yeah. So that's something that has gotten a lot of attention, and you'll see that type of goal reflected in many of these statements at the state and national level. But in order to do that, you can't hit net zero in 2050 if you're still going strong in 2040, right? For one thing, if we continue to emit at the same level that we are now, then we won't have much left in the bank account, and we'll have to get to net zero earlier, if that makes sense, right? Net zero by 2050 assumes a decline by 2030 that's pretty large. And if we don't start aiming at that, we can't get to zero by 2050. If we wait till 2030 to start cutting, we'll have spent down the bank account, and we got to get to net zero faster. We might have to get there by 2040 instead, right? So I feel like the goals that we're seeing at the state level and at the federal level are reasonably, well, I don't think the pledges for COP were good enough, but I think the net zero by the mid-century is where we need to be.
Well, and I see a lot of questions and sort of comments coming through too on the speed with which we can transition away from fossil fuels and bring renewable energy online. And I definitely sense that feeling of like concern from a lot of people. Well, we can't do it fast enough. We can't do it fast enough, so we need to go slow. But if we go slow now, is that going to impact what we have to do in like 10 or 20 years?
If we go slow now, we have to go way faster later.
Okay, so that could put us in a position where because we've kind of delayed in implementing things and not been very aggressive, all of a sudden we really have no choice but to be ultra aggressive.
Yeah. Or overshoot and face much greater risks, right?
Right. So there are a couple of different comments about the impacts on kind of working people and economic impacts. And I know that you're not an economist, but can you put into context for us, not in terms of economics, but like here in the Great Lakes state where we are often outdoors and we are often active, how is it that we can anticipate climate change impacting sort of our daily lives and the things that we will be able to do outdoors?
Yeah. So here in the Great Lakes, we are fortunate to be in a place in the US at least where the climate impacts are somewhat less than elsewhere. So for example, one of the things, but we still have threats here. So one of the things that we see clearly, for example, is the decline in winter recreation. That would be a biggie. And winter recreation is a big boon to the rural towns of northern Michigan, including the UP and the northern lower peninsula, things like snowmobiling and ice fishing. You need snow for those. Skiing, right? You need snow for those. And we are moving into a world where we are likely to see less and less snow, more rain, more slush, right? And less ice, right? So that's a big direct loss just from warming temperatures. Another thing that we would see here is the increasing prevalence of exceptionally hot days. And when the temperature hits 90 and the humidity is high, those start to be conditions where, unless you're right exactly on the beach, maybe in the water, it's not very comfortable to be outside and hiking and things like that. So that's challenging as well. So I think that we do see a big hit to outdoor activity here. It also becomes dangerous to work outside, frankly, if you're working in an agricultural situation or you're working in construction or landscaping and you're outside in the summer. The health risks to people in those professions become very high, and it becomes difficult to work full days.
And you would think that our neighbors to the in Canada would also have an interest and concerns about these same things. Have you seen a lot of collaboration with other governments, especially in North America, about issues like Line 5?
I can't really speak to that. Sorry, I don't really know much about the collaboration around Line 5. I mean, I have heard that Canada wants us to keep it because it's taking Canadian oil, the southward flowing part is taking Canadian oil to a Canadian refinery, as I understand it. So that's of interest, but I really don't know too much about how that is working out on a negotiation standpoint.
Yeah, and I actually just saw a question come through on the chat. That's kind of something I've been thinking about in the past few days as I work on this case, about how we transition folks if Line 5 is to shut down. How do we transition the folks who work in refineries, folks who rely on propane? And I just wanted to point out that there's some really great work that's been done on those issues by a lot of experts and a lot of our colleague organizations and by us, that talk about the different types of programs that the state of Michigan could engage in, and different techniques like improving access to storage, electrification and use of heat pumps. There are a lot of really great ideas about how to make that transition without it being, too abrupt and painful for certain groups. And I also wanted to point out that there are lots of jobs in the clean energy industry, right? So we're a country that has experienced many different forms of technological change. And every time that happens, I feel like there's a lot of concern, right, about, well, what's going to happen to the employees and, the buggies and carriages industry when the cars come online, and that there will be new jobs in that industry. And ELPC has done some work looking at things like the solar supply chain and how important that will be in the Midwest.
Yeah, that's right. I mean, industries evolve, and we don't make buggies anymore, but you don't hear about the loss of buggy makers. I think that another thing that I've noticed in reading about this is that, we need to separate two issues here. One is the long-term trend to reducing the need to reduce fossil fuel usage globally, right, is going to promote a change in this, whether Line 5 stays open or is a tunnel or what. On the other hand, shutting down Line 5 or not building the tunnel shuts down flow to particular places, but all of those refineries have multiple pipelines coming into them. So it's not like if you shut down Line 5, a refinery over here closes, right? There are multiple sources of crude coming into all these refineries, and they make a big deal of saying they have multiple sources because then they can maintain price stability. That's a business strategy. They would never depend on just one source. So I don't see that shutting the flow, to a refinery that would force it to close.
And your discussion of like a strategy, or use of the word strategy there, made me think of another question that I saw in the chat, which was about this term net zero.
Yeah.
Which I think it's really packed, right? And so I'd like to hear kind of what you think about it, whether or not it's meaningful, and what is the right way we should be thinking about carbon emissions from industry.
Yeah, net zero doesn't mean 0, right? It means net zero. And so there are ways to encourage the uptake of carbon dioxide from the atmosphere that either harness the power of natural systems related to, say, photosynthesis or storing carbon in soils, right? Or there's increasingly a lot of research being done on direct air capture of CO2 into rock or other types of systems where the CO2 can be trapped in a form, like a mineral form, that it can't escape back. So if you can balance your positive emissions with a negative emissions strategy, that's called negative emissions, right? Getting CO2 out of the atmosphere, then that can lead you to net zero. But we have to be a little bit careful here, right? Because a common strategy that you see is a company will say, well, we're just going to plant 1 trillion trees, right? I think that was a talking point on one of our political parties a few years back. And if everybody says they're going to plant 1 trillion trees, we don't have room for that, right? And plus, I have one word for you: wildfire, right? Wildfire is unpredictable and more common in a warmer, drier climate, and will take all that carbon that you've painstakingly sequestered and send it right back out again. So net zero does have room for emissions, because some things are very hard to replace, right, emissions-wise. Some things are easier, some things are harder. And we just have to be a little bit careful that we can't offset all of that with tree planting. And we need a much better understanding of how natural systems sequester and hold carbon, for example, in soils. Soils have the potential to be a great carbon sink, uptake sink that we could harness and increase sequestration in soils. But it looks like the ability of soils to do that depends on the climate of the area that you're talking about. And there's large ranges of how effective they are. So a lot of work needs to be done.
Yeah, it sounds like you're getting into really complicated questions, and just not emitting the carbon is a much more straightforward way to approach that.
That's exactly right. We hear a lot about complicated adaptation strategies. You know, should we try to build seawalls around coastal cities? Should we try to put white plastic on glaciers to reflect the sun's rays and not keep them from melting? All these crazy adaptation strategies that are kind of small and one-off and really expensive. We know how to solve this. The solution lies in renewable energy. That's where the solution lies, and stopping fossil fuel energy. Like, to me, it feels like we've made a lot of progress in those kinds of technology, utility scale wind and solar, in the last couple of decades, and that's where we should really be focusing.
Yeah, I'll say, and this, we probably need to sort of wrap it up pretty close here, so to end on a kind of a high note question.
Mm-hmm.
One thing I've been really impressed with in my work in Michigan is the degree to which people are really focused on trying to find solutions, right? And so to figure out what is the next step and how do we innovate and how do we make it good for Michigan and good for climate. And that's what kind of keeps me going when I get a little down on things. And I was wondering if you had sort of a thing that gave you the most hope in terms of this fight we're in.
Yeah, so I agree. It's very easy, and especially as an earth scientist who's focused a lot on the two areas I study are drought in the West and coral reef systems in the tropics. And so it's very easy to get depressed about these situations. And I won't lie, I do get depressed about them. But I also take heart in the fact that the kinds of renewable solutions that we're seeing are now cheaper than fossil fuels in many cases. And I just want to reiterate, brand new wind, brand new utility scale solar constructed from the ground up is cheaper in many cases than existing coal and existing natural gas plants. Think about that for a minute. That's amazing, right? And so if that is something that is happening because of the economies of scale in how we building solar panels and building wind turbines, right? As you have a brand new technology, it's very expensive. And then as you build more and more of it, you learn to do it more efficiently and you build more of them and the curve drops, right? So this is great. These are not commodities that you buy and they fluctuate in the open market either. They're technologies, and technologies get cheaper with time. So seeing that gives me hope that we can harness market forces, which I think are maybe too powerful, but very powerful, sure, in driving these kinds of changes. And if we can harness those market forces to drive towards renewables in a much bigger way, subsidize them appropriately, because don't kid yourself, we're already subsidizing fossil fuels, right? There's a reason that companies get tax breaks for drilling dry holes, right? We are subsidizing fossil fuels to an incredible extent. And the fossil fuel industry acts as if the renewable industry, can't work without subsidies. Well, they know better, right? So I do feel like we have some solutions on the table that we can apply. The other thing that gives me hope is working with young people every day here at the university and seeing the immense energy that they bring to this. So, yeah.
I can get on board with you with that one. My kids, who are 11 and 8, they probably know as much about this topic at this point as I do, and it's pretty impressive.
Yeah.
So, and it's great to hear, I think, that a lot of the work that we do at ELPC, we do a lot of clean energy work, we do, agricultural work with CAFOs, and it kind of all can come back in some way to climate change. And so it's great to see kind of that integration of our work and how it's helping us get to that goal.
It's all
so we're yeah, it is all connected. So we're going to have to wrap it up for today, but I do want to thank Dr. Julia Cole for joining us and for all of her important work in this space. Thanks to everybody who's joined us today and to all of your excellent questions. I'm sorry that I couldn't kind of get them all, and I tried to synthesize the best that I could to get some of those important topics in there. To learn more about Line 5 and ELPC's work on climate, you can go to our webpage at www.elpc.org. Keep an eye out for future ELPC Thinks invitations. And just thank you so much for being here, to Julia, to everybody who was so engaged in this topic. I hope everybody has a safe and happy holiday season.